All right, 2.4. So we're doing parallel and perpendicular lines. So I can write the equations of parallel and perpendicular lines. So we're going to have two equations each time. One for if we have two sets of parallel lines, and then two because if we'll have two sets of perpendicular lines. So parallel lines are two lines in the same plane that never intersect. So it's like railroad tracks. They always move together, right, both sides. They never cross, no matter what. They moved at the same rate. They move together at all times. So parallel lines have the same exact slope. That's what keeps them from intersecting. So the slope has to be identical. So if one is at slope of 2, the other one has to have a slope of 2. Now perpendicular lines are lines that intersect, but they form right angles. So they perfectly cross to cause a 90-degree angle, so like a T. So perpendicular lines have slopes that are opposites and reciprocals of one another. So, for example, if I had a slope of 2, its perpendicular slope would be -1/2. Opposite and flipped over. Okay, these are perpendicular. Like this. Now I also could have, if I had like -1/3, its perpendicular slope, I'd flip it over, that'd be 3/1, and then I take the opposite so it becomes positive. So those are perpendicular. And then it just says, it reminds you that reciprocal of a number is 1 divided by that number, or if it is already 1 over a number, then it's just flipped over to 3/1. All right, so here's our first practice. It says, what is the equation of a line in slope-intercept form that passes through the point 8, 9 and is parallel to the graph of y equals 3/4x minus 2? So this is my first line right here. This is line number 1. Oh, I wrote line number 2, line number 1. What we're trying to do is solve for line number 2. Okay, and we want it in slope-intercept form. Remember, that's y equals mx plus b. Just like this. And what they did is they gave us a point. So the slope will be 3/4 because they're parallel. Remember, parallel means the same slope. So I'm just going to take the slope and use it because I don't have to do anything. They're the same. What we are going to have to do, though, is now use this point. I don't care about this -2. Okay, we don't care about this. I care about the slope because they're parallel, and I care about this point. So what we're going to do is use point-slope form to find the rest of the information. So I'm going to take this point, right, this is my x and this is my y. I'm going to go y minus 9 equals my slope, 3/4, parentheses, x minus 8. So let's distribute first. So I'm going to go distribute, and we're going to get y minus 9 equals 3/4 x. Now here it's going to be minus, well, 24/4, which then just transfers to y minus 9 equals 3/4 x minus, and that's just 6. Now this is still not in slope-intercept form because I have to have a y equals, so what we're going to do is go plus 9, and then we get y equals 3/4 x plus 3. And there's line number 2. So now this line and this line are parallel because they have the same slope and they start at different places, and so they're going to just continue on in both directions together. So there's our answer. So you can see we used slope form and point slope form, and so that's why we need to know how to do all forms, because I had to use slope intercept form and point slope form. All right, so now it says, what is the equation of a line that passes through this point that is now perpendicular to this graph? Okay, so again, this is line 1. We're going to solve for line 2. So when the slopes are perpendicular, remember they're opposite and reciprocal. So the opposite of negative 14 is positive 14. Okay. The reciprocal of 14, right now this slope is m equals negative 14 over 1, right? So to flip it over, I just make it 1 over 14. So this is the slope for number 1, and this is the slope for number 2. Opposite, because see, one's positive, one's negative, and reciprocal, it's flipped over. That's the trickiest thing, is the perpendicular. It's got to be opposite, reciprocal. So now that we have the slope and we have a point, we can solve it. So we're going to go y minus 7 equals 1 over 14, parentheses, x minus 1. So again, we're going to distribute. We're going to get y minus 7 equals 1/14 x minus 1/14, because 1 times 1/14 is just 1/14. Then we're going to add our 7. So to add these, I'm going to do this over here. I got to technically do 7 over 1 and then times it by 14 to get them in common denominators. So 28 and 7, 8, 9. So 98 over 14. And then I subtract my 1/14th and we get 97 over 14. So now our final answer would be y equals 1 over 14x plus, because this was more, right, plus 97 over 14. And there's our final answer. All right, so now we have two equations, line 1, line 2. And we are going to prove if they are parallel, perpendicular, or neither. Now the first one is not in slope-intercept form or standard form or any form whatsoever, so we need to solve that. Let's solve that for slope-intercept form. And then we can compare their slopes and see if they are equal, opposite, reciprocal, or neither. All right, so when you solved this one, we should have divided by 3 to both sides. And you would have gotten y equals negative 4/3 x plus 2. So then what we're going to do is compare them, right? This is line 1. This is line 2. So the slope for line 1, I'm just going to put a little one right there, is negative 4/3. The slope for line 2 is negative 3/4. Well, they're not parallel because they're not equal, so not parallel. Now they are reciprocals, 4/3, 3/4, they are reciprocal, but are they opposites? They are not opposites. So the answer is neither, because they're not opposites. They have to be both. It cannot just be one or the other. They have to be opposites and reciprocals. So this would be neither. A landscaper plans to install 2 new paths in a park. The new fountain path will be perpendicular to the east path. This is the east path, this red one right here, and lead to the fountain. Here's our fountain. The new picnic path will be parallel to the fountain path. It's going to be parallel to the fountain path and pass through the picnic area. What are the equations in point slope form? So it's telling us that we can leave them in point slope form that represents the new paths. I'm reading this question. So we need to find the slope of the east path, because that's the only line we have, so that we can find the slope of the fountain path and then find the slope of the picnic path. So east path is this red line right here. It goes through the point 0, 2. Right, this is east path. And then to find a nice easy line, another point is right here at 5, 3. So we're going to use that to find our slope. So I'm going to take 3, take away 2, and I'm going to put it over 5, take away 0, and we get 1 over 5. So that's the slope of the east path. Now, it says right here that the fountain path is perpendicular to the east path. So we have to take the opposite reciprocal for the fountain path. So then the slope of the fountain path, I'll put FP, fountain path, is the opposite would be negative, and the reciprocal would this be flipped over, so 5. So the fountain path's slope is negative 5. And then I want to write an equation in point slope form for that. So let's take this point right here that the fountain path is at, which is 15, 2. Right, so the point is 15, 2. And then we're going to write in point slope form. So I'm going to go y minus 2 equals negative 5 x minus 15. Done. I don't have to put it in standard form, and I don't have to put it in slope-intercept form. So then it says that the picnic path is parallel to the fountain path. So we're going to put PP over here. Don't giggle. And the slope of the picnic path would also be negative 5 because it's parallel. Remember, parallel is the same slope. Now, we need to use the point for the picnic path. It is 5, 6. All right, so that's our point right there, 5, 6. And again, we're going to use point slope form, so y minus 6 equals negative 5, and then x minus 5. And we're done. Those are our 2 equations, point slope, parallel, perpendicular. All right, last problem. A neighborhood plans to build a rectangular park and plot its location on a grid. They gave us 3 of the vertices, negative 3, 0, 3, 2, and 4, negative 1. What are the equations of the lines containing each side of the park? So a rectangle has 4 sides, so we're going to need 4 slopes and 4 equations. And the nice thing about rectangles is that all the corners are perpendicular and 2 sides are parallel, okay? So I'm going to graph this. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And I'll use another color to graph so it's easier to see. So negative 3, 0 is right here. And 3, 2 is here. And 4, negative 1 is right here. So if I connect here to here, and I connect here to here, That's part of it. We know that the other part has to, the other walls are going to go over here somewhere, and then they're going to come over here somewhere. I don't know if that's the exact point, so don't quote me on that. Okay, these are my question mark sides. All right, let's find the slope from -3, 0 to 3, 2. Since we have it graphed, I'm actually just going to count. So I'm going to go up 2, and then over 1, 2, 3, 4, 5, and actually should be a little more, over 6. And 2 over 6 is the same as 1/3. So that's the slope of this one. And then, now if it's difficult to count, we can always subtract. So I could go 2 minus -1, so that's going to be this one here, over 3 minus 4. I'm going to get 3 over -1, which I can then just write as -3. Okay. So now we need to write some equations. We can at least start them. So we can write the equation of this one. Let's put a 1 here, and I'll put line 1. And we know the slope is 1/3. We also know it goes through this point. So I'm going to use point flip form. So y minus, well, 0 equals 1/3 x, and remember it's going to be plus 3. And if I clean this up, it's just going to become y equals 1/3 x plus 3. So now I have the slope for line 2. Let's put that as line 2. And I can still use a point. Let's use the point 3, 2. Okay, so I'm going to go y minus 2 equals -3 x minus 3. And it doesn't say which form. It doesn't say slope, intercept, or standard, or anything, so I'm going to stick with point slope because it's the easiest one to use right now. Now, our question marks are line 3 and 4, but what's really cool is that line 3 actually has the same slope as line 1 because they're parallel. It's a rectangle. So I can just use the slope from line 1. So for line 3, I'm going to use the point down here, the one I know, for -1. And I'm going to go y plus 1 because of this, right, double negative, equals 1/3 x minus 4. Nope, that was supposed to say line 3. Yeah, line 3. And then last but not least is line 4. That's over here. And it's now parallel to my line 2. And there's my slope for line 2. So for line 4, I'm going to go y minus, it goes through this point, so y minus 0 equals -3 parentheses x plus 3. And then I can clean it up as y equals -3 x plus 3. And we can also check our slopes that we did these right. This was 1/3. The opposite and reciprocal would be 3 over 1. So they are in fact perpendicular. I don't know what this y-intercept is or for these lines, but I'm not too worried about it because I just need the equation. So there's line 1, 2, 3, and 4. All right, so we are finally done. So remember, parallel is going to be same slope, and perpendicular Uh-oh. They can wait. It's going to be opposite reciprocal slopes. All right, so you have this question. Says, what's the equation of the line that passes through 4, -2 that is perpendicular to this graph? Okay, so that's the trick part, is that perpendicular piece. And we only care about the slopes. And then here is your point. All right, until next time. Sorry, glitching. Okay, bye.